Alright, here we are in the next video. Recall we just figured out that if we had our function sine x, then the derivative of sine x is cosine x. Now, you could do a similar situation. We get if we have f of x is cosine x, then we could use the limit definition and go through the different properties and prove that the derivative of cosine is really close to being just sine, but it's negative of sine. Okay, so this is how I always remember it. When you're writing out the trig functions, just to remember them, like SOHCAHTOA with the opposite over hypotenuse, you always write sine first. So in my opinion, sine is the nicer one, the nicer function. And then you then write cosine, and then you have to remember that there's a negative when you do the derivative. Okay, so we're not going to go through that proof. It's very similar to the one that we just did in the last video. But for now, I want to move on to this next example. So let's just consider our function f of x, and let's say it's cosine x. Then the derivative of cosine x, well, we just discussed, is negative sine x. Now let's take the derivative again. So we could write f prime of x and then its derivative, or we could write f double prime of x, or we could write f double prime, well, we have 2 but in parentheses, and that means you take the derivative twice. And so we can take the derivative of negative sine x. So like we discussed before, the coefficients along for the ride, and then you take the derivative of sine x, which we just proved is cosine. So we get negative cosine x for the second derivative of cosine. And then let's take the third derivative. So we'll take the derivative one more time. We have our coefficients along for the ride. We take the derivative of cosine x. We just discussed that the derivative of cosine x is negative sine x. And so then we got a negative times a negative, and we get a positive. All right, now let's continue on. Take the fourth derivative, so the derivative of sine x, and we get cosine x. And if you notice, we get right back to where we started from. So if we wanted to take the fifth derivative, we know exactly what it's going to be. We got negative sine x. If we wanted to take the sixth derivative, we know that it's the one after the negative sine x, which we got negative cosine x. And we see this nice repetitive pattern. And so the seventh derivative is going to be sine x, and then our eighth derivative is going to be back at cosine x. So it's really neat because if we really wanted to, we could find the 37th derivative, for example. And we just go through our pattern and see which one it is. And you can see that every multiple of 4 is going to give you cosine x. So if we write this as f of, let's see, 36 plus 1 of x. So 36 is a multiple of 4, so that's going to give us cosine x. And then we have to take the derivative one more time to get to 37. So that derivative is going to be negative sine x. Okay. All right. Now that was more just for fun, but just so you know in the future that if you can find patterns, we can keep on going. Okay. So if you remember, let me scroll up. We have discussed what it would be for our power rule if we had a coefficient, and then we added and subtracted derivatives. So what's the next thing that you talk about in elementary school, for instance? So you first add things together, then you subtract things together, And then eventually after that, you move on to multiplication. Now, multiplication is going to be a little bit more difficult with derivatives. It's not going to be as nice as adding and subtracting derivatives. So, and that's actually, we give it a couple of rules. And similarly, division is going to be the same. So, here we go. The next item on the list is to discuss the product and quotient rule. Okay, so the product rule first. So we have two functions, let's call them f and g, and then we take the derivative. Now, so we're multiplying them together. The product rule says you take f and then you multiply by the derivative of g plus g times the derivative of f. And that's the product rule. So whenever you have any two functions that you're multiplying together, you are required to do the product rule. Okay. So, let's do an example. Here we go. Let's say y equals x cubed times cosine x. We see that it is a product. So for instance, this x cubed is going to be what f of x is. That's our first function. And then this cosine x is the second function. So we multiply f and g together and get our original function back. Now let's use our product rule. So we have dy dx, or you could write y prime, equals, from the product rule, well, let's just write it out. F of x, g prime of x, plus g of x, f prime of x. Now, if you want to, off to the side, you could write this out. So f of x is x cubed. You take the derivative of f. It's the power rule. We bring down the exponent, and then the new exponent is one less. Next, we have g of x, which we discussed was cosine x, and we know that the derivative of cosine x is negative sine x. It's the not so nice one. All right, now we're ready to substitute into our function. So f of x is x cubed, the derivative of g of x, which we said was negative sine x, plus g of x, which is cosine x, and then times the derivative of f, 3x squared. Now what we want to do is manipulate this around. We got x cubed times negative sine x. Let's write the negative out front so we're really sure that it's not minus sine x. And we got x cubed times sine x. And then plus, let's write the 3x squared out front so we know it's not inside the trig function, and then multiply by cosine x. All right, now we could clean this up a little bit more. We notice that in both terms there's an x squared, so let's factor that out. We got a negative x left over, sine x, plus 3 cosine x. All right, and there we go. We found the derivative of this complicated function, and it was not so bad compared to using the limit definition of the derivative. Okay, in the next video we're going to look at some more product rules, and then